Let's be honest, messing with a database schema is one of the riskiest things a developer can do, especially when an application is scaling up. One little mistake and the whole thing can just grind to a halt. So today we're going to talk about how to take that whole process from the kind of chaos you might be used to and get it to a state of complete control using a tool called Liquibase. Okay, I'm pretty sure this question hits home for just about every developer out there. You've been there, right? You test everything, it's working beautifully on your machine, you hit deploy, and then, boom, disaster in production. It is just a terrible feeling. And you know what? More often than not, the database is the silent culprit. And yeah, this quote right here, this is the classic reason why. A single, totally forgotten, altered table command. That's all it takes to bring an entire service to its knees. And this isn't some made-up scenario. This is the reality for tons of teams who don't have a rock-solid database migration strategy. But here's the thing. That one forgotten command, that's just the tip of the iceberg. The real problem runs much deeper. When you're just managing SQL scripts by hand, you get devs overwriting each other's work. You have no idea which scripts ran on staging versus production, and trying to roll back a bad change, it's absolute chaos. You're practically guaranteed to get this thing called database drift, where every single one of your environments is just a little bit different. So, how do we get out of this mess? Well, it takes a whole new way of thinking. It's a total paradigm shift. We have to start treating our database like we treat our code. And this is the core idea right here. We're going to apply the same logic we use for our application code to our database. Every table definition, every new column, every index, it all gets defined in files that are checked into version control right alongside the rest of your app in Git. Every single change becomes a commit. It's trackable, it's reviewable, and it's totally repeatable. What you end up with is this amazing automated safety net that's built right into your deployment. Look at these steps. When your app starts up, before it can serve a single request, it kicks off Liquibase. Liquibase then looks at the database, applies any new changes it finds, and only after the migration is 100% successful does the app actually go live. And here's the best part. If that migration fails for any reason, the app just crashes and never even gets a chance to run against the wrong database schema. Okay, that all sounds great in theory, right? But how does it actually work? I mean, how does Liquibase know what changes have already been run and what's new? Let's pop the hood and take a look. You know, the secret is actually pretty simple, but it's also kind of brilliant. Liquibase just creates its own special table right inside your database. Every single time it successfully runs one of your migration scripts, it adds a new row to this database changelog table. It's a permanent, unchangeable record of everything that's ever happened to your schema. But wait a second. That brings up a huge question. What's stopping a developer from going back and, tweaking a script that's already been deployed to production? That could cause some serious problems. The answer? It's all about a digital fingerprint. For every single migration script, what Liquibase calls a change set, it calculates a unique MD5 checksum. It then stores that fingerprint in the tracking table. Now, every time the application starts, it recalculates the checksum from the file in your code. If those fingerprints don't match, it means someone changed the file, and Liquibase will stop everything dead in its tracks to protect the database. And this is so important. It means your change sets are immutable. Once a change has been run, it is set in stone. You cannot change it. If you need to fix something or add something, you don't edit the old script. You create a new script to make the change. This enforces this really clean, forward-only history of your entire database schema. All right, but what about the real world where you've got multiple servers spinning up at once during a deployment? How do you stop, say, 5 different application instances from all trying to run the same migration at the exact same time and creating a massive race condition? Liquibase has another clever trick up its sleeve for this, a lock table. It's simple. The very first server to start up grabs a lock on this table. That makes it the one and only instance that's allowed to run the migrations. All the other servers, they see the lock is taken and they just wait patiently. Once that first server is finished, it releases the lock. The other servers see the migrations are done and they just continue starting up. It's clean, elegant, and totally safe. Now, of course, Liquibase isn't the only game in town, so let's take a look at how it stacks up against some of the other options you might run into, so you can see why it's such a solid choice. First up, you've got Hibernate's Auto DDL. And oh man, is it tempting. It just magically creates your entire database schema by reading your Java code.
It's fantastic for a quick prototype, but it is dangerously unpredictable in a real environment. It might decide to just drop a column with all your user data because you renamed a variable. That's why this is a feature you never use in production. Liquibase, on the other hand, is the safe, controlled path that's built for production from the ground up.
Then there's Flyway, which is a fantastic tool, super popular. The real difference here comes down to philosophy. Flyway is all about raw.sql files, which is awesome if you love writing SQL. Liquibase, however, uses an abstraction layer. You can use XML or YAML or JSON to define your changes in a way that's database agnostic. And here's a huge win for Liquibase. For a lot of common changes, like creating a table, it can automatically generate the rollback command for you, like dropping that table. That saves you a ton of manual work.
Okay, so we've talked a lot about the why and the how. Let's actually see what this looks like inside a real project, in the codebase itself. Everything starts with this one master file, and its job is super specific. It contains absolutely zero schema changes itself. Its only purpose is to act as an orchestrator, basically a playlist that defines the exact chronological order that all the other migration files need to be run in.
And if you look inside, it's exactly what I mean. It's just a clean, simple list of include tags. Each one points to a specific file that handles one piece of the puzzle, like creating the initial schema or adding the tables for the billing feature. It gives you this perfect, high-level story of your database's entire evolution. So, what's actually in one of those files it includes? Well, that's where the magic happens. The actual changes are broken down into one or more of these change sets, and you can just think of them as the smallest possible unit of change that Liquibase is going to track and validate. And this is what a single change set looks like. You've got a unique ID, an author, but look closely at what's inside. We're not writing raw SQL here. We have a descriptive tag, create table. This is that powerful database agnostic abstraction we were talking about. Liquibase sees this and translates it into the correct SQL for whatever database you're connected to, whether that's Postgres or Oracle or SQL Server. So let's pull all of this together. When you step back, what's the real impact of doing things this way? It's really about that fundamental shift we talked about, from chaos to control.
This is why it matters so much. First, your database schema now lives in Git under proper version control. This leads directly to predictability and safety because you have automated checks like checksums preventing corruption and locks preventing race conditions. This, in turn, guarantees consistency across all your environments, finally killing those but it works on my machine bugs. And ultimately, you get a resilient system, one that's designed to fail safely and stop the application before it can cause a bigger problem.
And that really brings us to the final question I want to leave you with. Think about it. Your application code and your database schema are so tightly connected. So if your schema isn't in version control right alongside your code, can you honestly say that your application is truly under your control? It's something to think about.